They told us bridges must start from land, concrete foundations first, massive towers second, and only then, the span across the water. But this project breaks every rule ever written in structural engineering. Because this bridge builds itself. In the middle of the ocean, far from ports, far from cities, far from any traditional construction site. Just water and wind. If you enjoy impossible machines and futuristic mega projects like this, subscribe to the channel, because this is where engineering begins to look like science fiction. Out on the open ocean, waves stretch for hundreds of kilometers in every direction. No land, no cranes, no foundations. Just endless water moving slowly under the sky. Yet here, something enormous appears on the horizon. At first, it looks like a fleet of industrial ships. But these are not cargo vessels. They are something entirely new. Self-assembling bridge factories. Each one the size of a city block. Each carrying thousands of tons of steel lattice structures, composite cables, autonomous construction machines. They did not arrive to build the bridge. They arrived to become the bridge. Slowly, the ships begin to align across the surface of the ocean. Gigantic hydraulic clamps deploy between their hulls. One by one, the floating factories lock together, forming a straight mechanical spine stretching across the water. But this is only the beginning. From inside the platforms, colossal robotic towers begin to rise. Steel frameworks unfold like mechanical skeletons reaching into the sky. Massive stabilizers descend deep into the ocean, anchoring the platforms against the waves. Even during storms, the structure holds position within centimeters. Now the real construction begins. Inside the floating factories, autonomous fabrication arms start producing the bridge itself. Instead of transporting beams across continents, the beams are manufactured directly above the ocean where they will be used. Molten steel flows through continuous casting systems. Robotic welders fuse gigantic trusses together with impossible precision. Crawler cranes lift finished sections high above the water. And slowly, the first span begins to grow. Unlike traditional bridges, this structure does not extend from land. It grows forward from its own edge. Every new segment locks into the previous one. The bridge becomes its own construction platform. Behind the leading edge, stabilization cables deploy automatically. They descend hundreds of meters into the dark ocean below, connecting to gravity anchors resting silently on the seabed. These anchors hold the bridge steady against currents and storms. Above the deck, massive pylons begin to rise. But they are not poured from concrete. They are assembled from ultra-light composite structures stronger than steel. Cable systems stretch between the towers like enormous metal spider webs. Each cable thicker than a human torso. Each capable of carrying thousands of tons of tension. Slowly, the bridge begins to take shape. A line of steel stretching across the endless blue horizon. But the ocean has its own rules. Storm waves crash against the structure with enormous force. Wind gusts push against the towers with hurricane strength. Traditional bridges would struggle to survive here. So this bridge does something different. It moves. Hidden deep inside, massive gyroscopic stabilizers begin to spin. Enormous flywheels counteracting the motion of the sea. When waves strike, the stabilizers adjust the balance of the entire structure. The bridge flexes slightly, absorbing energy instead of resisting it. It behaves less like a rigid building and more like a living structure floating above the ocean. Meanwhile, the construction platforms continue moving forward. Segment after segment extends into open water. Behind them, the finished deck becomes a functioning highway. Inspection drones patrol the cables. Autonomous scanners analyze every weld and joint. Self-healing coatings seal microscopic cracks before they can grow. The bridge does not simply exist. It maintains itself. Months pass, then years. And eventually, the impossible happens. Two advancing construction fronts meet in the middle of the ocean, thousands of kilometers from the nearest coast. One final segment rises slowly into position. The last connection, the final lock. Hydraulic clamps pull the two halves together. Sensors measure tension across every cable and beam. Alignment lasers confirm the structure is perfect within millimeters. And then, the final weld is complete. A continuous bridge now stretches across the ocean, so large it can be seen from orbit. Cargo vehicles begin crossing within hours. What once required ships and weeks of travel now takes a single day of driving. Entire continents become connected. Trade routes shift. Cities grow along the corridor. And somewhere far below, waves continue crashing against steel. But the bridge remains. Calm, balanced, self-sustaining. Because this was never just a bridge. It was the first structure designed to build itself. And once engineers prove something like this is possible, the ocean will no longer be a barrier. It will simply become the next place we build. But the story of this bridge does not end with the final weld. Because what engineers created here is more than a single structure. It is a new way of building the world. For centuries, oceans have divided continents. They slowed travel. They shaped trade routes. They defined the borders of civilizations. But a bridge that can build itself in the middle of the sea changes everything. Now imagine what comes next. Entire floating construction fleets deploying across the planet. Machines capable of assembling highways across oceans. Rail systems stretching between continents. Energy pipelines connecting distant coasts. Megastructures once considered impossible slowly becoming reality. If you enjoy exploring machines like this, machines that push engineering beyond imagination, make sure you subscribe to the channel. Because every week we break down the most unbelievable industrial technologies ever imagined. And some of them may soon become real. Back on the bridge, traffic begins to flow day and night. Autonomous trucks cross silently above the waves. Sensors monitor every vibration, every gust of wind, every shift of tension within the cables. The bridge is constantly learning. Artificial intelligence adjusts stabilizers in real time. Maintenance drones patrol the structure without human crews. Tiny robots inspect the cables millimeter by millimeter. When corrosion appears, microscopic repair systems activate instantly. The structure quietly heals itself. From above, the bridge looks almost peaceful.